Hello friends, welcome to Learner's Planet. Friends, this is our sixth session for mensuration. In the previous session, we did some problems based on various 2D and 3D shapes. We did some simple problems. Then we did the problems based on mensuration and percentage. In this session also, we'll be taking some problems based on percentage and mensuration. To revise the previous sessions before coming to this session. So now let's begin the session. Friends, let's discuss some percentage-based mensuration problems. This sort of problems I have discussed in my percentage sessions. You may attend those sessions so you will feel comfortable in this session. Okay. Now, there are two types of variables, that is independent variable and dependent variable, and always there exists a relationship between these two, right? Now this relationship is can be in various types, right? Now suppose here if we see in the first question that if the every side of a scalene triangle is doubled, then what is the percentage increase in area of the triangle? Now you know that the length of the side will always be in meter, isn't it? Meter or maybe centimeter, something like that. So unit of side will be meter or centimeter or maybe any other linear unit. But unit of area will be meter square, centimeter square, kilometer square, something like that, right? So this is a linear unit, this is a square unit. And what is the relationship between these two? That is side and area. So it's the unit of this is in a square and unit of this is in meter. That is linear. Okay. So whatever impact is going on side, the impact corresponding impact on area will be in square times, right? Now how do we get that? How do we establish that? Suppose I take an example of a scalene triangle, and any scalene triangle may be a right angle triangle also. So for simplicity, I'm taking the example of a right angle triangle. This is 3, 4, 5 right angle triangle, right? Any other Pythagorean triplet you can also take. Now, area of this triangle is what? Half of 3 into 4. That is 4 3s are 12 by 2, 6. Okay. Now, if I double the sides, if I double each side, then it will be 6, 8 and 10. Now what will be the area of this triangle? That is 8, 6 are 48 divided by 2, 24. So initially the area was 6, now the area is 24 because we doubled each side. Why? Because the dependency, that is the relationship between side and area is what? Area is half length into breadth, that is length and breadth, both the things are there. Okay, so while we calculate or while we do percentage based mensuration problems, we don't have to take the basic data as 3, 4, 5 or any other number. For simplicity, we can take the data as 10 or maybe 100. So area is equal to half length into breadth. Okay, suppose I assume the length and breadth both as 10. Okay, so 10 into 10, this half is constant, so whatever is the increase in length, maybe percentage increase in length and breadth, this half will remain constant. Okay, so we don't have to take this particular number into consideration. Okay, so initially the area is 10 into 10, that is 100. Now if each side is doubled, so it's 20 into 20, it's 400, right? So initially the area was 100, now the area is 400. So what is the percentage increase? That is 300%. Okay, now it doesn't matter that we are given that the triangle is scalene. Okay, and we are taking both the sides as same. It's not necessary because we are making a percentage increase calculation. So basic data can be any number. Okay, if at all you have been asked about exact increase in numbers or exact increase not in percentage but in terms of numbers, then you have to take the data as different. Okay, otherwise as far as percentage cases are concerned, you can take the basic data as same, right? So we have to see the relationship among these two, maybe dependent and independent variable, right? Similarly, we can see this example. If the each side of a square is increased by 25%, find the percentage increase in area. Now, what is the relationship between side and area? That is length into length is area. Okay. So, first, as usual, we will be taking the initial values as 10 and 10. So, area is 100. Now, this this length is increased by 25%. So, the new length will be 12.5 into 12.5, so it will be 156.25. Okay, so what is the increase? That is 56.25%. Okay, so it's quite easy. If the radius of a circle is decreased by 50%, the area of the circle will be increased by what percent? Further, what is area? A is pi r square. Area of a circle is pi r square. Further, we will assume the radius as 10 and pi is constant. So we will not take this into calculation. So further, 10 into 10 is 100. Now radius is decreased by 50%. That means the new radius is 5 into 5, that is 25. So 75 is the decrease on 100. That means 75% decrease in area will be there. Getting me? Initially it's 100, now it is 25. So what is a percentage decrease? That is 75. Okay. Every time we are getting this 100 and percentage difference from 100 to get for percentage difference from 100 is very easy. Now, if the circumference of a circle is increased by 10%, what is the percentage increase in its area? Now, circumference C is 2 pi r. It's a linear dependency on radius. Okay. So, if radius is increased by 10%, circumference will be increased by 10%. Or we can say if circumference is increasing by 10%, that means radius is also increasing by 10%. Okay. So, if radius is increasing by 10%, we can calculate the increase in area. Further, 10 into 10, because the formula will be same. So it's initial area. Now 11 into 11, that is 10% increase in radius. That comes to 121. So it's 21% increase in area. Okay. So everywhere we are taking the basic values as 10. So we can immediately calculate the percentage difference, because percentage difference have to be calculated on 100. Okay. So I hope you are getting me. Now, area of a circle is increased by 96%. Find the percentage increased in radius. Quite a simple problem. Initially, I assume the radius to be 10. So 10 into 10, that is 100 is the area. Now the new area is 96% increase. That means the new area is 96% of 100. That is added to 100. That means 196. Now this is the new radius, r into r. Now r square is 196, that means r will be 14, right? So it's 10 into 10, now 14 into 14. So initially 10, now 14, that means 40% increase. Okay. So if area is increased by 96%, that means radius is being increased by 40%. That's this. I hope you're getting me. Quite a simple problem. After some practice, you can do this sort of problems even mentally. Okay. The length and width of a rectangle is increased by 20% and 30% respectively. Find the percentage area increase in area. Further, 10 into 10 is 100. Length is increased by 20%. Though it is a rectangle, we will assume the length and breadth as same to simplify or for simplicity. So now the new length will be 12 and the new breadth will be 13. So 12 into 13, 156. So it's 56% increase in area. Okay, it's very simple. The length of a rectangle is increased by 30% and width is decreased by 20%. What is the percentage effect? Further, 10 into 10, 100. Length is increased by 30%, that is 13. Width is decreased by 20%, that is 8. That is 20% we are decreasing from 10. So 13 into 8, 104. So it's 4% increase. Okay, quite simple. The length of a rectangle is increased by 50% and width is decreased by 50%. What will be the percentage effect in area? Various times this sort of questions are asked in examination, and the students think one thing is increased by this X percent and other thing is decreased by X percent. That means there is no impact at all on area. But it's not like that. Just see the calculation over here. Initially it's 10 into 10, 100. Now it is 15 because length is increased by 50% and breadth is decreased by 50%, so it's 5. Now what we are getting, that is 75. Initially the area was 100, now it is 75, so it's a 25% dip. Okay, or we can say 25% area will be reduced. Okay, so by this method the problems become very simple, right? Further, if the length of the side of a triangle is increased by 4% and altitude is decreased by 4%, what is the percentage change in the area? Now, what's area of a triangle? That is half base into altitude. Further, half will create no impact or half will give no impact to the calculation. So initially we assume that base into area, base into this altitude, the area is 100. Okay. Now this length is increased by 4%, so the new length is 10.4, and altitude is decreased by 4%, so the new altitude is 9.6. Okay, now we have to calculate this, multiply this two. So it's 9984. That means it is 99.84. So 100 minus 99.84, we can say 0.16% decrease in the area. Okay. Now, if the length and breadth of a rectangular park are increased by 50% and 20% respectively, the new area. Okay, first simple, it's 100. Now it is 50% increase, so it is 15. It's 20% increase, that means it is 12. 15 into 12 is 180. So this is old area, this is new area. Now we are asked that the new area is how many times the original area. So it's 180 by 100. It's 9 by 5 times. Okay, quite a simple problem. Further, if the height of a triangle is decreased by 30% and base is increased by 40%, what will be the effect on its area? Now you can do this problem mentally. How to do it? 10 into 10, initial area is 100. Now height is decreased by 30%, that means the new height is 7, and base is increased by 40%, that means the new base is 14. Now 14 into 7, that is 98. Initially the area was 100, now the area is 98, that means there is a 2% decrease. So this sort of problems can be done without paperwork in less than 30 seconds. Okay, so just practice with that. Okay, I hope you will be clear with this method. Now friends, I would just suggest you just pause the session and try the problems on your own and match your answer and solution with mine. Okay, so there are 3 problems. You should not take more than 2 minutes to solve all of them. Okay. Now, the width of a rectangle is decreased by 60% and the area remain unchanged, then the breadth has been increased by. Initially, this 10 into 10 is 100. Now, width is decreased by 60%. That means the new width is 4. Length we have to find out, and the area is still 100. So, length is 100 by 4, that is 25. So initially it was 10, now it is 25. So what is the increase? That is 15, and 15 increase is on 10, that means 150% is the increase. Okay, no need to go for any sort of paperwork. Just listen to me carefully. It's 10 into 10, 100. You can visualize like this, 10 into 10, 100. Then width is decreased by 60%. That means the new width is 4. We have to find out the new length. Area will be 100 only. So new length will be 100 by 4. That is 25. Initially the length was 10. Now it is 25. So it is 15 increase over 10, that means 150 increase over 100, that means 150%. Okay, so quite simple. Further, if all the sides of a hexagon is increased by 5%, find the percentage increase in area. Quite simple problem. Sides is in meter and centimeter, maybe linear unit you can say, and area is in square unit, so the impact will be in squares only. So if side is increasing by 5%, initial area will be 10 into 10, 100, or you can say for simplicity initial area is 10,000. Now the new area is square of 105, that is 11025. So increase is 1025 on 10,000. So from 100 the increase will be 10.25. So from 100 the increase is 10.25, that means it is 10.25% increase. Okay. Now if the diameter of a circle is increased by 25%, find the percentage increase in circumference. Now circumference is also linear function and diameter is also linear functions. So whatever the increase in diameter, the same percentage increase will be there in the circumference. So that's 25% only. No need to go for any sort of paperwork. So friends, I hope you are clear. Now similarly try this problem. If the sides of a rectangle are increased by 100%, find the percentage increase in its diagonal. Further, side is a linear function and diagonal is also linear function. So whatever is the increase in the side, the same percentage increase will be there in the diagonal. Okay, no need to go for any sort of paperwork. Now, if the length and two diagonals of a rectangle are each increased by 20%, then find the percentage increased in breadth. Further, diagonal is a linear function with unit centimeter or meter. Similarly, this breadth is also a linear function that with unit centimeter or meter. So whatever is a percentage increase in diagonal's length, the same percentage increase will be there in the length of the breadth. So there is 20% increase only. No need to go for any sort of paperwork. Okay. Now the length of a rectangle is halved while its breadth is tripled. What is the percentage change in area? Now just try to visualize. Initially the area is 10 into 10, 100. Now length is halved, that means the new length is 5, and breadth is triple, that means the new breadth is 30. So 30 into 5, 150. Initially the area was 100, now the area is 150. So what is the percentage increase? From 100 to 150, it is 50% increase. Okay. So no paperwork is required at all. I'm sure you are clear with this type of problems. Now let's try this question. A regular hexagon is inscribed in a circle of radius 10 centimeter. We have to find out the area of the shaded portion. Okay. So first of all, we know that the area of circle is pi r square. And what is the area of hexagon? Area of hexagon is just a Now this is center of the circle. Now this is hexagon, and in fact it is a regular hexagon. So this length is A and this length is also A, because this is both the lengths will be same since it is radius of the circle. Now since it is a regular hexagon, all these there will be 6 equilateral triangles like this. Okay. Now if the triangles are equilateral, that means this length is A, this length is A, that means this length will also be A. So area of hexagon will be what? It is 6 times area of an equilateral triangle. Now what is the area of an equilateral triangle? That is root 3 by 4 side square. So root 3 by 4 side is A square, and this sort of 6 triangles are there. So this is the area of the hexagon. Now what is the area of the circle? That is pi r square. So it's pi into r square. R square means A square. Okay. You can take A square as common. So it will be pi minus 3 root 3 by 2. So this you have to solve. Now here radius is given to us as 10. I just put the value of A as 10 and solve it. Now friends, you can go for approximate calculation because it will take a long time to, if you go for actual calculation, just get an around idea of the calculation. Since these three are the integral values and our answer will be definitely in fractions, so these three are eliminated. Now we just have to see whether our answer is around this or not. Okay, because we are also given none of these. So it's 1.732 into 3 divided by 2. That means 3 divided by 2 is 1.5. So 1.7 into 1.5. So 1.7 into 1.5, that means 1.5 times of 1.7. That will be, you just add half of 1.7 to it. So that will come around 2.6. Now from 3.14, if you deduct 2.6, you will be getting something around 0.54. So it's 0.54 into 100, that is around 54 will be the answer. So our answer is coming closer to it, so we can choose it. Okay. So I hope you are clear with the method. Now let's try this problem. A circle of radius 10 centimeter is inscribed in a regular hexagon. Find the area of the hexagon. We have a circle that is inscribed in this regular hexagon. This is center of the circle and center of hexagon as well. Now there is an important property, that is tangent to the circle. Now this is the side of the hexagon. And simultaneously it is tangent to circle. Now what happens? Whenever we drop a perpendicular from center to tangent, the length of this perpendicular is equal to radius of the circle. So in this case, this length will be equal to 10 centimeter, that is radius of the circle. Okay. Now it will be an equilateral triangle. As I have already told you in the previous question that in a regular hexagon from center, if we drop lengths like this on the vertices, we will be getting 6 equilateral triangles. Okay. That means these three angles will be of 60 degree. Okay. So now what do we have? A situation like this, where this length is 10 centimeter and these, this and this, these three lengths are equal. Now I assume this length to be 2x and this complete length is 2x, but this will be x. Okay, because this length will or we can say this perpendicular will bisect the length, since it is an altitude to equilateral triangle to the from this vertex to opposite side. So if this length is 2x, this length will be x. Now we can apply Pythagoras theorem to find out the value of x. So it's 4x square is equal to x square plus 100, right? Hypotenuse square is equal to base square plus perpendicular square. Okay, so 3x square is equal to 100, so x square is equal to 100 by 3. Now this area of the hexagon is 6 times this area of an equilateral triangle. So what is the area of equilateral triangle? That is root 3 by 4 side square. Side square is what? It is 2x whole square, that is 4x square. This is the area of single equilateral triangle, and there are 6 equilateral triangle like this in this hexagon. So it is 6 times root 3 by 4 into side square. Now just put the value of x square as 100 by 3 and we will be getting the area of the hexagon. Okay, so it's 200 root 3 square units. Okay, I hope you are clear. Now let's try this question. Further, we have to find out the area of the shaded region. In the figure, find the area of shaded region if ABC is an equilateral triangle of side 6 centimeter. Now friends, what is the area of an equilateral triangle? That we know. What is the area of the circle? Formula for area of circle, that we know. Now to find out the area of this shaded region, what we have to do? We have to find out the area of equilateral triangle, and from that area, if we subtract the area of the circle, right, we will be getting the area of the remaining region. Okay, so what we have to do? We are given the side of the equilateral triangle. So first of all, we have to find out the radius of the circle. Now quite similar as the previous question was, this is tangent to the circle. Okay, and this is center of the circle. So if we drop the perpendicular from center of the circle to this tangent, it will be equal to radius of the circle. So this is radius of the circle that I assume to be r, right? Now we have this right angle triangle. Okay, now this complete length is 6 centimeters, so this will be half of the length, that is 3 centimeter. Okay, now this complete angle is 60 degree, and this, since this is an equilateral triangle, the center from this center, if we drop a line to this vertex, this line will work as an angle bisector. So if this complete angle is 60 degree, this angle will be of 30 degree, right? Now we have this sort of triangle. This is R, this is 3, and this is 30 degree angle. Now we have to find out this length. Now you might have studied trigonometry in your junior classes. Which trigonometric function gives the relationship between perpendicular and base? That is tan theta. So here theta is 30 degree. So tan 30 degree is equal to perpendicular by base, that is R by 3. So R by 3 is tan 30 degree, and tan 30 degree is 1 upon root 3. So R is equal to 3 by root 3, or we can say root 3. Okay, so we got the value of radius of the circle. So area of circle will be pi r square, that is pi into 3. That is area of circle. Now what is the area of equilateral triangle? That is root 3 by 4 into side square. Now side square is what? 6 into 6, that is 36. So this is the area of triangle, that is 9 root 3, and this is area of the circle, that is 3 pi. So this is the area of the remaining portion, or we can say the shaded region. Okay, so 3 you just can take common. So here 3 root 3 minus pi. That will be the correct answer. So it is 3 root 3 minus pi. Okay. Friends, I hope you might have enjoyed the session. We'll be doing more such problems in our next session. See you. Bye-bye.